So today we're going to talk about the angles of elevation and depression. And if we look at this picture here that we clipped from the book, we know that from this kite to the little girl, we actually have this angle of depression. And if we look from the little girl to the kite, it's actually the opposite. It's the angle of elevation. So the first thing that we need to look at is just identifying angles of elevation and depression. So if we look at the first example, example 1A, we see that angle 1 is an angle of depression from the bird to the person in the hot air balloon. So you start with the plane that the bird is flying along. This is the path, and then that is actually an angle of depression down to the hot air balloon. If we look at 4 and we go from the base of the mountain from this plane actually to the hot air balloon, we notice that that is an angle of elevation. So let's look at number 2 or angle 2 and 3. If we look at angle 2, we notice that angle 2 is from the base of the mountain actually up is going to be an angle of elevation. But when we look at angle 3, from the base of the mountain down, that's actually an angle of depression. So it all depends on what plane you start from. Okay, so angle 2 is actually going to be an angle of elevation. And if we look at angle 3, that would actually be our angle of depression. Okay. The next thing we look at is, suppose we have these angles, what could we determine from them? How could we figure out what the actual height here of this turbine is, or whatnot, using trigonometry? And here is a video that you can click for additional examples as well of this same topic. But we'll start with the wind farm, and this is the angle of elevation. So suppose you stand 53 feet from the wind farm. So here's your 53 feet here. This is your base length. Your angle of elevation to the hub of the turbine is 56.5 degrees. So we're saying angle of elevation here is 56.5. Our eye level is 5 feet above the ground. So that means this right here is going to be 5.5 feet above the ground. Okay, so approximately how tall is the turbine from the ground to its hub? So once we find x, we're going to have to actually add x to 5.5. So if I look at this angle here, 56.5, I have the adjacent side, and x is going to be the opposite side. So I am going to use the tangent function. So I'll say the tangent of 56.5 equals, and again, tangent is opposite over adjacent, so that would be x over 53 feet. And I'll just punch that in my calculator and see what I get. Okay, so in my calculator, I punched tangent 56.5, and of course I use my parentheses to try to group that, times 53 equals x, and that gives me about 80. Okay, so now I know that it's about 80 feet from here to the end. So about right here, it's going to be about 80 feet. Okay, but remember, I do have to add that 80 back to the 5.5 feet. So that's going to give me a total of about 85.5 feet for the height of that wind farm turbine. The next thing we look at is this rock climbing problem, and it reads that you have a rock climber on a cliff at a 32-degree angle. So here's the angle, and your eye level is about 6 feet above ground. So here's my eye level, and so about 6 more feet here, right, is going to be the ground. So I'm going to write 6 feet right here, and that's going to give me the ground. Okay, and I am about 1,000 feet from the base of the cliff here. So it looks like I'm still looking for this opposite side. So I'm going to say the tangent now of 32 degrees, right, is going to be equal to x over 1,000. Okay, so I'll just plug that in my calculator. Okay, and that's going to give me about, it looks like 625 feet roughly, if I round to the nearest whole number. Okay, but don't forget I have to add that 625 back to the 6 feet, right, to get their height from the ground. So if I do that, it's going to be, the rock climber at least, is going to be 631 feet above the ground. Next, we're going to use this angle of depression, and I also have another video link here for you to go to if you need additional examples for this one. But now we're going to talk about depression, and we say the approach to the runway 17 of this municipal airport in Oklahoma. The pilot must begin its descent at 3 degrees, starting at a height of 22,714 feet above sea level. The airport is 1,007 feet above sea level. To the nearest tenth of a mile, how far from the runway is the airport at the start of the approach? So this is a little bit different because we're saying that from the angle here, from the original descent to the airport, we have one height, and then we also have an additional foot for sea level. So we say that the airport is about 1,007 feet above sea level, and that this entire degree is going to be, or this entire distance here, is going to be 2,714 feet above sea level. So if we subtract those values, we would see that the airport to the beginning or initial descent would actually give us 1,707 feet. We're looking for the distance from the airplane to the airport, so we're actually looking for this value, which we need to say from 3 degrees is actually the adjacent side, and we're given the opposite side. So we can still use tangent, right? We can still use tangent, and actually we're looking for, I read the problem wrong, we're looking for the hypotenuse, so we cannot use tangent. I apologize. We are given the height here, and we're looking for the hypotenuse. So we need to use what? We have 3 degrees, we have the opposite side, we have the hypotenuse, so we actually can use sine for this one. So the sine of 3%, right, is going to be equal to opposite, which is 1707, over the hypotenuse, which is x. Okay, so of course if we cross multiply for this one, we'll end up with the sine of 3% times x equals 1707, and that will allow us to again divide by the sine of 3%. And let me just punch that in calculator and see. Okay, it looks like that gives us about 32,616.2 feet. It looks like it asks us to the 10th of the mile. So in order to get that into miles, we're going to have to divide by 5,280 feet per mile. And if I divide that out, it looks like we get about 6.2 miles. Is the length of the descent from the airplane to the airport, or the hypotenuse. Okay, for the next one, we're going to have an airplane here. And of course, that's not a very well drawn airplane, but you can get the picture. And the airplane is going to spot a lifeboat. So we have a little lifeboat here, and we're going to determine the horizontal distance that we have for this airplane to the lifeboat. So what we have is the distance from here to here is what we're going to be looking at, and what is given is this height as 3 kilometers. So we can write here that this is 3 kilometers here. And we know that this descent is going to be from here to here. This angle of depression is 26 degrees. So here to there to the lifeboat, here giving us an angle here of 26 degrees. And so of course we want to know this horizontal distance. And we know that if this is 26 degrees here, then this here is going to be 26 degrees, and we're going to use our opposite and our adjacent sides. So for here, I'm going to say the tangent, right, of 26 degrees is going to be equal to 3 kilometers over x. Okay, of course we can cross multiply, and what we'll find is that x is going to be equal to 3 divided by the tangent of 26 degrees. So let's punch that in. Okay, and we see that that is going to be about 6.2 kilometers from there. Okay, so you guys need to work on the practice problems 9 through 22. Okay, won't take too long, and probably you can get them done in class, and we will review them on Monday. Okay, so good luck, and if you need extra pointers, be sure to go back and watch the video links that were provided.